Discovery and why. 3. I-Atlas matters. Tri-Atlas was first detected on July 1st by the Asteroid Terrestrial Impact Last Alert System, ATLAS, a network of telescopes that scans the skies for fast-moving objects. At the time of discovery, it was about 675 million kilometers from the Sun, far beyond the orbit of Mars. From the very beginning, astronomers realized this comet was special. Its orbit wasn't an ellipse like normal comets that loop around the Sun. Instead, it followed a hyperbolic path, which means it came from outside our solar system and will not return. That single detail instantly placed 3I Atlas in a very rare category. It became only the third known interstellar object ever observed, following 1I Oumuamua in 2017 and 2I Borisov in 2019. Unlike asteroids or comets that belong to our solar system, this one is a true visitor from another star, passing through on a one-way trip. Even more intriguing is its incredible speed, about 130,000 miles per hour, 210,000 kilometers per hour. It's moving too fast to be captured by the Sun's gravity, so it will eventually leave our solar system and continue its journey into deep space. Astronomers are excited because 3I Atlas carries chemical and physical clues from the place where it formed, a star system far beyond our own. By studying it, scientists get a rare chance to compare how comets form and evolve in other parts of the galaxy, offering a glimpse into worlds we may never reach. Historic Mars Flyby and ESA's Observation Challenge. In early October 2025, the interstellar comet 3I Atlas made history as it passed near Mars during its journey toward the inner solar system. For astronomers, this was a once-in-a-lifetime opportunity. The comet came close enough to be seen by spacecraft orbiting the red planet, offering a unique chance to collect data that would otherwise be impossible from Earth. To seize this moment, the European Space Agency, ESA, aimed two of its Mars-orbiting spacecraft at the visitor, the ExoMars Trace Gas Orbiter, TGO, and the Mars Express Orbiter. Both spacecraft turned their cameras toward 3I Atlas, hoping to capture detailed images of this rare interstellar traveler. However, the attempt proved far more difficult than expected. The Mars Express Orbiter failed to capture any usable images because the comet was simply too faint for its instruments. The challenge was summed up by ESA's team. Observing 3I Atlas was like trying to photograph a candle flame from thousands of kilometers away. Even the more advanced ExoMars TGO, equipped with the CaSSIS color and stereo surface imaging system camera, had to push its limits. ESA scientists described the comet as being 10,000 to 100,000 times fainter than our usual targets. Despite these hurdles, ExoMars managed to capture images showing the comet as a faint, fuzzy point of light. This moment highlighted both the technical challenges of observing such distant, dim objects and the ingenuity of modern spacecraft, turning Mars into a front-row seat for studying an interstellar visitor. ExoMars CaSSIS camera results. The CaSSIS camera on ESA's ExoMars Trace Gas Orbiter became the star of the show during the Mars flyby of 3I Atlas. Despite the incredible distance, about 30 million kilometers from the comet, the camera successfully captured its image. CaSSIS is a highly capable instrument. It has a resolution of 11.36 microradians per pixel, which translates to about 2.34 arcseconds per pixel, or roughly 340 kilometers per pixel at that distance. That sounds impressive, but here's the challenge. The comet's nucleus is tiny, estimated to be somewhere between 5 and 46 kilometers across. In simple terms, it was far too small to be directly resolved by CaSSIS. Instead of a crisp, detailed core, the comet appeared in the images as a small, fuzzy, bright dot. This glow wasn't just the comet's nucleus, it was the Coma, a halo of gas and dust released as the comet warmed while approaching the Sun. Even though the camera couldn't pick out the solid heart of the comet, these observations were still a major success. Capturing a faint object like 3I Atlas from millions of kilometers away is no small feat. The images gave scientists a clearer look at the Coma's brightness and structure, helping them track how the comet changes as it moves deeper into the solar system. It's a reminder of how even the fuzzy dots in space can tell us powerful stories about distant, alien worlds passing briefly through our neighborhood. Insights on the Coma and outgassing. One of the most fascinating things about the new images of 3I Atlas is the clear view of its Coma, the glowing halo of gas and dust that surrounds the comet's icy core. In the recent observations by ESA's ExoMars CaSSIS camera, the Coma appeared as a bright, hazy cloud stretching several thousand kilometers across. This halo forms as the comet gets closer to the Sun. The Sun's heat warms the icy nucleus of the comet, causing it to release gas and dust into space. These particles spread outward, creating the glowing envelope we see. It's like watching the comet wake up as it approaches the inner solar system. ESA scientists described interstellar comets like 3I Atlas as absolutely foreign, reminding us that unlike other comets in our solar system, these visitors carry clues about the formation of worlds in distant star systems. Interestingly, despite being closer to the Sun than during earlier observations in July by Hubble, the data from CaSSIS showed no major increase in outgassing. This suggests that 3I Atlas is behaving in a surprisingly stable way, offering astronomers a rare opportunity to study its natural state as it continues its journey through our cosmic neighborhood. Brightness and size estimates. The new ESA observations of 3I Atlas with the CaSSIS camera revealed a fascinating picture of the comet's brightness. CaSSIS managed to capture a bright inner region about 680 kilometers wide, shining like a small glowing core. However, it's worth noting that the Hubble Space Telescope, during its earlier observations in July, had detected a much larger 4,000-kilometer wide glow stretching outward toward the Sun. This difference isn't because the comet changed dramatically, but rather because of the instruments used. Hubble's larger mirror and higher sensitivity allowed it to see a faint outer envelope of dust and gas, something the CaSSIS camera simply couldn't detect during its recent attempt. The actual size of the comet's nucleus is still one of the most intriguing mysteries. Based on its brightness and non-gravitational movement, estimates suggest it's at least 5 kilometers wide, but it could be as large as 46 kilometers. Adding to the excitement, data from NASA's SphereX mission indicates that 3I Atlas's CO2 gas plume might extend an astonishing 348,000 kilometers into space. This incredible scale shows how active the comet is as it continues to approach the Sun, shedding material that reveals more about its interstellar origins. Comparisons and viewing angles. One of the most interesting aspects of the new ESA observations of 3I Atlas is how they compare with earlier images taken by the Hubble Space Telescope. Back in July, Hubble observed the comet while looking directly toward the sun-facing side. From that angle, the comet appeared to have a long, glowing tail stretching out in the direction of the Sun's light and solar wind. When the ESA's ExoMars Trace Gas Orbiter, TGO, turned its CaSSIS camera toward the comet during the Mars flyby in October, it viewed 3I Atlas from a completely different angle, perpendicular to the glow's axis. This new angle didn't just give another snapshot of the comet. It revealed more structural detail in the region around the bright inner core and Coma, providing insights into how the dust and gas spread as the comet moves. Of course, there were limits. The CaSSIS camera's mirror is only 13.5 centimeters wide compared to Hubble's massive 2.4-meter mirror, which meant CaSSIS couldn't achieve the same high resolution. Yet this unique side-on perspective from Mars gave scientists valuable data that complemented Hubble's earlier sun-facing view, helping build a fuller picture of the comet's appearance and activity. Future and upcoming observations. The story of 3I Atlas is far from over. While the ESA's ExoMars TGO captured valuable images during the Mars flyby, other spacecraft are also expected to contribute. Both China's Tianwen-1 mission and the UAE's Hope orbiter were in position to observe the comet as it passed Mars. Their images are likely to be lower in resolution, but they could still provide helpful supporting data. The most eagerly awaited images now come from NASA's HiRISE camera on board the Mars Reconnaissance Orbiter, MRO. HiRISE can achieve an impressive 20 km per pixel resolution, which may help narrow down the size of the comet's nucleus. Unfortunately, the release of these images has been delayed due to the ongoing U.S. government shutdown, leaving astronomers and the public waiting for the next big reveal. Looking ahead, the ESA's JUICE mission will get a chance to observe 3I Atlas next month, likely when the comet reaches its most active state near its closest approach to the Sun on October 29, 2025. Even further in the future, the planned ESA Comet Interceptor mission, launching in 2029, may one day intercept an interstellar comet like 3I Atlas, offering an unprecedented close-up view. Scientific takeaway. The biggest message from all the Mars-based observations of 3I Atlas so far is clear. It's behaving like a natural comet, with no signs of alien technology or anything artificial. The data collected by ESA's ExoMars TGO and other Mars orbiters show the same familiar processes: ice warming in sunlight, gas and dust streaming out, and the comet continuing on its predicted hyperbolic path through the solar system. ESA scientist Colin Wilson praised the work of the orbiters, noting that it's always extra exciting to see them responding to unexpected situations like this one. This highlights just how versatile these spacecraft can be, not just for studying Mars, but also for catching rare events like this interstellar visitor. The real power of this effort comes from combining data from multiple sources: Hubble's early observations in July, the new CaSSIS images from Mars, and the much-anticipated HiRISE and JUICE data still to come. Together, these observations are expected to refine estimates of the comet's size and reveal more details about its outgassing activity as it approaches the Sun. In the end, all of this adds to our growing understanding of rare interstellar visitors, helping scientists learn more about how distant star systems form and evolve.